Ever wondered why, despite the Earth spinning at over 1000 miles per hour, we don't feel a thing? It's a question that has piqued the curiosity of many. You see, our planet is in constant motion, spinning on its axis at breakneck speed, and yet, from where we stand, it seems perfectly still. It's a fascinating paradox, isn't it? In this video, we're going to delve deep into the science behind this phenomenon. We'll explore the concepts of rotation and revolution, and how they play a role in our perception. We'll unravel the mystery of inertia and how it affects our daily lives. And finally, we'll examine the role of gravity, the invisible force that keeps us grounded. Each of these elements contributes to our perception of a still Earth, despite its constant motion. So, buckle up as we dive into the science behind this intriguing reality. To comprehend why we don't feel the Earth spinning, let's understand the concepts of rotation and revolution. Picture yourself standing on a spinning globe. The Earth rotates on its axis, an imaginary line passing through the North and South poles. This rotation is what gives us our 24-hour day. From sunrise to sunset and back again, the Earth completes one full rotation every 24 hours. It's a dance that's as old as the planet itself. Now imagine a slightly larger scale. Not only does the Earth rotate, but it also revolves. This revolution is the Earth's yearly journey around the Sun. As the Earth traces this colossal circle, we experience the changing seasons, a direct result of our planet's tilt and its revolution around the Sun. Now, you might be wondering, if our world is constantly in motion, spinning and whirling through space, why don't we feel it? The key lies in the consistency of these movements. The Earth doesn't randomly speed up or slow down. It doesn't swerve or lurch. Instead, it spins and revolves with remarkable consistency. This constant steady motion is why we don't feel flung off into space or even slightly dizzy. It's akin to riding in a car cruising down a highway at a constant speed. You don't feel the speed itself, but you would certainly feel it if the car suddenly stopped or swerved. The Earth's rotation and revolution are not just fascinating concepts of planetary motion. They're fundamental to our daily lives, dictating the rhythm of our days and seasons. They're the reason why we can predict when the sun will rise and set, and why we can plan for summer's heat or winter's chill. Now that we have a basic understanding of these movements, we can move on to why we don't feel them. Understanding the Earth's rotation and revolution is the first step in unraveling the mystery of our seemingly still world. So, buckle up as we delve deeper into the science of our spinning Earth. Ever heard of the term inertia? It plays a crucial role in our perception of the Earth's motion. Let's dive a little deeper to understand this fascinating concept. Inertia, in the simplest terms, is the tendency of an object to resist any change in its motion. If an object is at rest, it wants to stay at rest. If it's moving, it wants to keep moving. This is a fundamental principle of physics, first articulated by the great Sir Isaac Newton in his laws of motion. Now imagine you're in a moving car. As long as the car is moving at a constant speed, you feel comfortable, right? That's because you, the car and everything inside it, share the same motion and thus the same inertia. But what happens when the car suddenly stops or turns? You lurch forward or to the side, don't you? That's your inertia, resisting the change in motion. Now, let's apply this to our spinning Earth. Our planet is rotating at a speed of roughly 1,000 miles per hour. But remember, we're rotating along with it. Just like in the car, we share the same motion and hence the same inertia with the Earth. This is why we don't feel the Earth spin. We're all in this spin together, so to speak. But what about when we jump? Why don't we land in a different spot because of the Earth's rotation? Well, that's inertia again. When we jump, we carry the Earth's rotational speed with us into the air, and it helps us land in the same spot. But don't let this fact make you feel small or insignificant. It's quite the opposite. It's a testament to the predictability and consistency of the laws of physics that govern our universe. And it's a reminder of how we're all intrinsically connected to this spinning planet we call home. So, inertia is the unseen force that keeps us grounded despite our planet's speedy spin. Gravity, an invisible force that keeps us from floating off into space, also plays a role in this phenomenon. The Earth spins, yes, but why don't we feel it? The answer is gravity. This unseen force holds us firmly on the ground, making us feel as though we're standing still, even though we're spinning with the Earth at over 1,000 miles per hour. Gravity works in tandem with inertia, the tendency of objects to keep moving in a straight line unless acted upon by an external force. Our inertia wants to keep us moving in a straight path, but gravity pulls us down, creating a sensation of standing still. This is why we don't feel the Earth's rotation. So, the next time you're standing outside, remember that you're not just standing on the Earth, you're spinning with it, kept in place by the invisible forces of gravity and inertia. Without gravity, not only would we feel the Earth's rotation, but we'd also be floating off into space. Let's recap what we've learned today. We've journeyed through the concepts that help us understand why we don't feel the Earth's spin. Starting with the Earth's rotation and revolution, we understood that our planet spins on its axis and orbits the Sun simultaneously. This double motion, however, is so consistent and smooth that we, as inhabitants, don't perceive it. We then delved into the concept of inertia. Remember, inertia is the tendency of an object to resist changes in its state of motion. Since we're moving with the Earth, our inertia matches the Earth's, making us oblivious to its rotation. Finally, we discussed gravity, the force that keeps us firmly grounded. Gravity, coupled with our matching inertia, ensures we don't fly off into space due to the Earth's spin. It's this intricate dance of rotation, revolution, inertia, and gravity that makes our experience on Earth stable and predictable. So the next time someone asks why we don't feel the Earth spinning, you'll have the scientific answer ready. Thanks for tuning in.